Welcome, dear students. We were discussing the topic uh, recently related to the amines, that is, aromatic compounds containing nitrogen. In that, we have already dealt with two different subtopics, that is, aliphatic amines as well as aniline, which is the aromatic amine. Now, here we are going to discuss a third part of this lesson, that is about diazonium salt. The word may be familiar for you when we were discussing the chemical reaction of aromatic amines, that is which is commonly named as aniline. We have already came through this diazonium salt. Here we will be discussing some details related to diazonium salts as a compound. Now, related to this chemical, what all are there for us to learn as per our syllabus? One, it is preparation of diazonium salt from aniline. So that is one concept that we should understand. Next, different chemical properties or different chemical reactions in which diazonium salt is involved. And thirdly, the importance of diazonium salt in synthetic organic chemistry. So these are the basic concepts what we need to learn related to diazonium salt. Now, first, let us understand what is diazonium salt. Here, diazonium salt, they can be represented with general formula, that is ArN2X. Now, Ar, as we know, it is an aryl group, that is a benzene ring. If you just consider aryl group means a benzene ring. So that is this aryl group. And to that aryl group, the nitrogen, how many nitrogen is there? Two nitrogen. So one nitrogen, then another nitrogen. These two nitrogen atoms are bonded with triple bond, right? And then another one atom is there that is represented with X, which can be chlorine, chloride, bromide, or bisulfate, or such anionic units which can join here. Now, since nitrogen is making a triple bond with the other nitrogen, here it is gaining a positive charge, and this makes the other one anion to get bonded with it. So this will be the complex formed. So this is how the structure is of a diazonium salt. You can see how it is a aryl unit, two nitrogen atoms, and an anion. This is what we represent with the general molecular formula, that is Ar(N2X), right? Now, here this nitrogen, as we said, it is two nitrogen atoms are bonded together with a triple bond, and this is what we name as diazonium ion, right? Now, azoate is the name given for nitrogen in a foreign language, and two nitrogen when it is coming there, that's why we name it as diazonium. And since it is not like the neutral N2 molecule, here it is how the two nitrogen atoms are there, they are bonded with the triple bond, and it is gaining a charge, so it is remaining as an ion, so we call it as diazonium ion group, and that is joined to a negatively charged anion. Now, here we are having certain very common salts of this type. First, it is benzene diazonium chloride. You can see this is the benzene part, this is the diazonium part, and this is the chloride part. Now, if you go with this molecular formula, it can be named as benzene, then diazonium, then HSO4 minus, that is hydrogen sulfate or bisulfate. So this is benzene diazonium bisulfate or hydrogen sulfate. Now another one, here you can see what is this part? It is benzene diazonium bromide. And to the para position means the position opposite to it, that is the para position, there is one chlorine, so we can call it as para chlorobenzene diazonium bromide. This is para chlorobenzene diazonium bromide. Now here if we just go with another one compound which come under this group, here you can see two benzene rings are there. Wherever there is two benzene ring, it can be named as naphthalene, right? And here what is that? It is this diazonium chloride, and to that the naphthalene ring is attached. So this is alpha naphthalene disodium chloride. Now, just for your knowledge, we are not recommended to learn the IUPAC naming or structural details of this compound. What we need is preparation, chemical properties, and certain its importance in synthetic organic chemistry. So this was just an introduction for us to get familiar with the compound, that is disonium salt. Now we come with the preparation process, and here we need to go specifically with the preparation from aniline. Aniline, we know what is that, aromatic benzene ring, and to one of the carbon NH2 is attached. So that is the uh, aryl amine, or we call it as aniline. Aniline, when undergo the process called diazotization, it will be providing or giving the product disonium salt. So that is the process. We, in a very simple way, we can say aniline or aryl amine undergo diazotization to give disonium salt. Now we will just go through and try to understand what is the process happening when aniline is undergoing diazotization. So here you look. Solution of aniline is taken in dilute HCl, and the important condition is that it should be in ice cold temperature. To that, slow addition of sodium nitrate is done, and sodium nitrate also should be in what temperature? Ice cold temperature, right? And when the reaction proceeds, we will be obtaining the product. Which product? The disonium salt, and here it will be benzene disonium chloride. You can see sodium nitrite and HCl, it will be in the system, it will produce nitrous acid. Okay, let's see what is the reaction happening. Aniline, it is taken in HCl. So here what will happen? Some uh, hydrogenation process happens, and you can see the hydrogen gets attached here, and it will be producing NH3 unit, which we name as anilinium ion, right? So it will be having NH3 plus charge. To that, the Cl minus is getting attached, so we can call it as anilinium chloride, right? So that is anilinium chloride. This anilinium chloride, in the system there will be nitrous acid produced by this reaction. So it interact with this nitrous acid units, and here some changes happen. The hydrogen present here will be removed out, and the nitrogen of this nitrous acid also will get attached there. So thus it will be producing the chemical which we name as benzene disonium chloride. Now benzene disonium chloride, it is in a solution form, it is with water. To if we to extract this disonium salt from water in crystalline form, that is not a easy process. So that's a little additional facts related to that. You can see isolation of benzene disonium chloride salt, or any, not only chloride, any salt in crystalline form is difficult. What is the reason? Two specific reason. One, this is highly soluble in water, and you can see even in that temperature, in the very cold temperature, that is ice cold temperature, it shows signs of decomposition. So if it is crystallized, if we try to crystallize it and remove all the water, it will decompose in a very fast rate, as if in an explosive way. So we can say the explosive nature as well as high solubility in water. Because of these two reasons, it is not practical to crystallize these diazonium salt by removing all the water. So that is a important point. And so itself, what is that done? Always when this is needed as a reagent in the chemical industry, it is always prepared freshly in ice cold solution and used directly. So that is how we use. So you can get a question, why disonium salt are not stored? Why always when it is needed we freshly prepare it and use in ice cold solution? So there you will get the reason for that. So that was the details related to the preparation process of this disonium salt. Now we come to the next point, that is chemical properties, in which we need to go through certain reactions specifically mentioned. One, it is Sand-Meyer's reaction. Another, it is Getterman reaction. Then replacement of diazo group by hydrogen, hydroxyl or nitro groups. Now, other than that, one more, that is coupling reaction with phenol and aniline. Of this first three come under one group. That is where in the disonium salt, that diazo unit is involving in the reaction. So these three reactions come under that set. And when the where the benzene ring is involving in the reaction, so this coupling reaction is coming under that group where the benzene ring is involving the reaction. Well, let's understand the details related to that before going with the chemical reaction involved. We will just understand the chemical nature of this salt. Now, there is could be one question whether aliphatic compounds produces disonium salt, and the answer is that even primary aliphatic amines can produce disonium salt. They are highly unstable. So itself, it's when a compound is not stable, we cannot use it. It just forms in between as an intermediate, and then it get restructured. So we cannot extract it as a compound, as a molecule, because it's highly unstable. So itself, it is not in use in the chemical world. But the disonium salt formed by primary aromatic amines, which we were mentioning here, they are stable. Now, we already said they start decomposing when we try to crystallize it, but still they are stable, and the stability of these compounds can be explained with the help of their resonance structures. So this disonium salt can have four different resonance structures. You can see here the nitrogen being electronegative attracts this electron, and it moves towards nitrogen gain, and this nitrogen gains uh, lone pair electron, two more lone pair of electron, and I can see there is only two bonds now, and that causes the double bond here to shift to this position, and this carbon gains a positive charge. Likewise, there will be a delocalization of electron, and the positive charge also moves from one position to another inside this benzene ring, right? So likewise, when we consider four different structures are possible for this disonium salt, and we have already learned that when there is possibility of more resonance structures, increased number of resonance structures means higher stability. So the presence of, or the ability of the compound to attain different resonance structures makes the compound to gain a resonance stabilization, and thus we can say this disonium salt formed by primary aromatic amines, they are uh, having stability. Even if it's short time, it has stability, and it involves in the different reactions as a compound. Now, when we consider the different reactions in which this disonium salt involved, all those reactions can be generally classified into two different groups. One, it is in which the disonium unit is involved and causes a displacement of nitrogen, releasing nitrogen gas. That is one. The other, it is, so here the two different sets of chemical reactions. One, it is the reaction involving displacement of nitrogen present in the diazo unit, and in such reactions there will be release of nitrogen gas. And the second set of reaction, that is reaction in which the diazo group is retained, it is not involved, right? So these are the two different types of, or two different categories of reactions in which disonium salt involves. Now we will go with the first one, reaction involving displacement of nitrogen with the liberation of nitrogen gas. And here the among the different reactions, we are recommended to go with few of those. One, it is displacing nitrogen, that diazo unit, and hydrogen taking the place. Another, it is hydroxyl getting replaced in the position of diazo unit. Then chlorine or bromine taking the place of diazo unit. And another one, that is nitro group replacing the position of diazo group. And in this, the chlorine and bromine involving reaction, though there we give a specific name, that is Sand-Meyer's reaction, and a modified form of Sand-Meyer's reaction is named as Guttermann's reaction. Now please note it, these two names terms are there in the syllabus, so itself it's important for us to have a clear understanding about it. Now we will go with each of these reactions. First, it is replacement by hydrogen. Now here you can see what is happening. This is diazonium salt. It is treated with hypophosphorus acid in presence of cuprous ion. So hypophosphorus acid is the reagent and cuprous ion is the catalyst. And here what will happen, this diazo unit will get replaced. There the hydrogen will take the place and the benzene or the aromatic unit will be produced. Let's see what is happening. The aqueous solution of diazonium salt treated with hypophosphorus acid in presence of cuprous ion as the catalyst, the diazo unit get replaced with hydrogen and corresponding aromatic hydrocarbon will be produced. So you can see here H1 takes the place in from C5 C6H5, it will become C6. Here what is the molecular formula? Here the formula is C6H5 and then this part. So this is removing and a H is getting added. So here what is the formula? C6H6 will become the formula. So here we can say it will get converted to the corresponding aromatic compound or aromatic hydrocarbon. So that was a replacement of azo group with hydrogen. Now when it is hydroxyl group taking the place, what could be the product? Here there will be an OH coming and then it will become the phenol. So that's about the next reaction. You can see the aqueous solution of diazo salt, it is treated with few drops of sulfuric acid and then what? It is boiled or it is subjected to steam distillation. And now what will happen? The diazo will get replaced with OH and the corresponding phenol will be produced. And here also you can see nitrogen released. Here also you can see the nitrogen released. So here the diazonium salt in the structure, please note here it is N triple bond NCl in aqueous medium. It is treated with sulfuric acid and it is boiled to give the phenol as the product compound. So that was replacement of diazo unit with hydroxyl group. Now with nitro, the direct replacement is not possible. So first an intermediate is formed by making the diazo chemical, the diazo molecule to react with a specific reagent. And what is that? Hydrogen borate. Listen once again, hydrogen tetrafluoroborate. So this is made to react with the diazos. And here what will happen? There will be removal of HCl happening, which results in the production of what? An intermediate complex, and that complex is named as diazonium tetrafluoroborate. Right? Diazonium, that is this benzene ring and nitrogen, that is diazonium, then tetrafluoroborate. So that is the intermediate product, and then it is treated with sodium nitrate, aqueous solution of sodium nitrate in presence of copper powder. Right? In presence of copper powder. So again what will happen? That here the sodium take out this BF4. Sodium will take the BF4 from here, and then the nitrous unit will get attached over here and the nitrogen will be removed from it. Right? So that's about just note it one more. Here it is N2Cl, the Cl is removing, so the nitrogen, that is 2 itself. Okay, N2Br4. This is here this N benzene ring with the N2, that is what is diazonium, and then BF4, that is tetrafluoroborate. So here it is benzene ring, then N2BF4. So here this hydrogen takes this chlorine and the HCl is removed. Then to that nitrogen N2BF4 is getting attached, which is taken by sodium. And this nitrogen is released as nitrogen gas. And the NO2 occupies the position. So that's about this reaction where the diazo unit is indirectly replaced with the nitro group. Right? So that's about the other one reaction. Now we move to the next one, that is replacement of diazo group with chlorine or bromine. Here also the catalyst is the copper containing salt. So if we want to make the substitution of this iso unit with chlorine, we should use copper chloride or cuprous chloride in presence of HCl, and it should be heated. So you can see aqueous diazonium salt with cuprous chloride and the corresponding halogen acid. When that is taken, you can see the chlorobenzene along with the release of nitrogen is happening. Instead, if it is cuprous bromide and hydrogen bromide, we said already cuprous salt as well as halogen acid. So which we want? We want bromine here, means we should use cuprous bromide and hydrobromic acid, right? So here the displacement takes place and we will be getting bromobenzene, release of nitrogen, and this chlorine will be removed from here in the form of cuprous chloride. So that's about the reaction, and this is the reaction what we name as Sandmeyer's reaction. Now in the Sandmeyer's reaction itself, when it is made a little more simple by not specifying any specific salt of cuprous, we are just taking copper powder as the catalyst along with the halogen acid. Only that change happens. Then what will be happening? The same, the diazo unit gets replaced by chlorine or bromine, and there's that reaction we specifically, when it is simplified, the Sandmeyer's reaction, when it is modified, then we name it as Gutterman reaction, right? So here you can see the diazonium unit, copper powder and HCl making this same product, chlorobenzene, and here copper powder and hydrogen bromide making bromobenzene. Here there, in all these cases we saw one point, that is release of nitrogen. So here we were discussing the different chemical reaction involving the diazonium salt, in which the azo unit is replaced by different radicals. Now we come to the next set of reaction. What is that? Reaction involving the retention of diazo unit. The diazo unit is not getting moved. That is what is happening. So here those reactions can be of three different types, that is reduction process, reaction with alkali, as well as coupling reaction, of which we are recommended only to go with the coupling type of reactions, and that also coupling with phenol and coupling with an aniline. Only these two are recommended for our learning. So before going with the details of coupling reaction, we will try to understand what is this coupling reaction. You can see the diazonium salt is treated with highly reactive aromatic compounds like phenol, aniline, etc. And then there will be, here there is a benzene ring, and for phenol or aniline there is again another benzene ring. The two benzene ring come together and join through a nitrogen-nitrogen double bond. You can see nitrogen-nitrogen, you can see nitrogen-nitrogen double bond. So likewise, this structure when is there, this functional part when it is there, we name it as azo compound. And the very special thing about azo compound is that they are all highly colored compounds, right? So you can see the azo compounds, how they are: aromatic ring, another aromatic ring, both the aromatic rings are joined with ENN double bond. So that's about this reaction. And here the coupling of diazonium cation with the phenol or aniline, there will be no loss of nitrogen, there will not be any release of nitrogen. Again, we said aromatic, reactive aromatic compound. So if you just consider phenol is what? The benzene ring, and here OH is there, right? To this, the benzene ring of diazonium salt is getting attached, right? Now this addition, when it happens, if it happens to the opposite position, we call it as para position. If it is any of these two position which is close to the one functional group, we call it as ortho position. Now here these two positions, they are called meta positions, right? Now according to nature of the one substituent present, the next coming electrophile will join any of this position. Now since here the two substituent present, which all are the substituent present? The OH and NH2. We already said the diazonium salt is reacting with phenol. Phenol means having OH, and aniline, that is having NH2. So these two radicals which is present as a substituent in the benzene ring, they direct the new coming electrophile to which position? Para position. So that is the nature of these radicals. Now in case if para position is already occupied with some other group of atoms or atom, then what will happen? Then the coupling takes place at the ortho position, right? So that is what is happening. Now let's see what with one example. This is disonium salt, this is phenol, and look, one specific thing. This reaction is usually taking place where the pH is very high. It means alkaline medium. Now what will happen? You can see this is the phenol and para position is free. So this unit will get attached there. Thus you can see the Cl gets removed, then N double bond N and this benzene ring. So what we can call it? We can call it as para hydroxyazobenzene, right? Para hydroxyazobenzene. So this is coupling with phenol, right? Now, we already said about a presence of a particle in para position. Then what will happen? So, let's see what will be happening. The diazo unit with phenol, but the para position of phenol is occupied with another group of atom. Likewise, when it is there, what will be happening? You can see this di this this much, this will get attached to the ortho position, right? And then the product formed, you can see it is 2-phenyl azo 4 methyl phenol. Now the important thing, more than the name, what is important, this is a azo dye and it is having orange color, like methyl, orange and all, they are azo compounds. So the characteristic color, deep bright color, that is a special thing about this azo compound. And here you can see the phenol unit to the second position, there is a SO part present, and 1, 2, 3, 4, 4 position, there is a methyl part present, right? So this phenol is what? Here this phenol is named for this as the root compound. This is taken as the root compound. So this is the phenol part, and again now positions we are taking. So we are numbering it in this way so that the lower possible number is got. So likewise this will get 2. So then we can say 2-phenyl azo. This is phenyl azo. This is phenyl azo. And then in fourth position methyl. So that is 2-phenyl azo 4-methyl phenol, which is an azo dye and it is having the characteristic orange color. Now here, so that was about phenol as well as the phenol which for which the para position is not free. Now we come to aniline. Aniline, when we consider, okay, this is the azo group and this is the aniline. It is now this reaction is preferred to take place in acidic medium. You can see pH is maintained less than 7, that is 4.7. So 4.5. So here the reaction takes place and the intermediate product is first formed, which again gets rearranged. You can see this is the NH2 to here. It is getting attached like this, and again a rearrangement takes place and we will be finally getting what? Para amino benzene. We can see para amino benzene, and this is also an azodite and it is having a characteristic yellow color. So that's about aniline. Aniline reacting with the disonium salt. Now so that's about the different reactions. We already said about the coupling reaction with phenol and coupling reaction with aniline. Now we come to the next, that is importance in synthetic organic chemistry. So this is a useful compound because it can be used for the preparation of different organic compound. So that's about it. Very useful. Replacing azo group by other groups help in preparing substituted aromatic compounds. It helps in the preparation of substituted aromatic compounds. Certain aromatic compound we can't prepare it directly, so we need to just make a substituent and then from that we should extract it. So in such cases, this is used as this compound comes as the intermediate product. Now azo dye production, azo dyes, different colored dyes in textile industries and all, these azo dyes are very important, and for the preparation of azo dyes these disonium salts are used. Then it acts as intermediates in the synthesis of large variety of organic compound, and here there is a quick look. You can see aniline undergoing diacetylation with the sodium nitrate and HCl in ice cold condition to give the diazonium salt. This diazonium salt is reacting in different manner, in different situations, and different products are obtained. So all these cases, this is acting as an intermediate, or this is helping for the easy production of these compounds. So almost all of them we have already discussed when we were discussing the chemical properties of aniline or this benzene disonium chloride. So that's about the different uses of benzene disonium salt as an intermediate for the preparation of different organic compounds. So with that, we have completed the topic of amines. uh, Now it's important to go through the questions and try to answer the questions which is present in previous question paper. So with that, the 13th unit, it is completed. Thank you.